Good morning to all. Today's topic is when all the root are distinct. For our problem 2, find the eigenvalue and eigenvector for the given matrix. So first step we have to write the characteristic equation. We know that the characteristic equation is nothing but determinant of A minus lambda I equal to 0. In this format I am going to write it. So it's nothing but 2 minus lambda minus 2. So 3, 1, 1 minus lambda, 1, 1, 3 minus 1 minus lambda. The determinant equal to 0. So next step I have to find the determinant for this. Before finding the determinant, I will use a shortcut to find out the determinant or normal multiplication the determinant. You can do it. It's not wrong. Okay. So the shortcut is lambda cube minus S1 into lambda square plus S2 into lambda minus S3 equal to 0. Okay, now S1 is nothing but sum of the diagonal elements. So sum of the diagonal elements. So it is nothing but 2 plus 1 minus 1. Sum of the diagonal element is this is okay 2 plus 1 minus 1. So it is nothing but 3. So 3 minus 1 it's nothing but 2. Okay. So S2. S2 is the sum of the minor diagonal elements. Minor of the diagonal elements. How to calculate it means minor diagonal elements means okay, so the determinant is nothing but 2 minus 2. So 3, 1, 1, 1. So 1, 3 minus 1. So what are all your diagonal elements? So minus 2 is your diagonal elements, 1 is your diagonal elements, and minus 1 is the diagonal elements. So when you consider the first diagonal element, leave your corresponding row and column, the remaining element. So it's nothing but 1, 1, 3 minus 1 plus the second diagonal element. Second diagonal elements when you consider, leave out your the corresponding row and column remaining elements. So it's nothing but 2, 3, 1 minus 1. The third diagonal elements. The third diagonal elements leave out your row and column corresponding elements. So 2 minus 2. So 1, 1. Do the calculation for this. That is the answer for the S2. So minus 1. So minus 3. So minus 4. So minus 2. Minus 3. So minus 5. So 2 plus 2, 4. So minus 5 only. S1, S2 is minus 5. So completed. S3 is nothing but determinant of A. This determinant you can calculate in a calculator. You will be getting the answer to be 6. Okay, so all the three data we have calculated is nothing but lambda cube minus 2 lambda squared minus 5 lambda plus 6 equal to 0. This is a cubic equation. Cubic equation you can solve in a calculator or normally means without the calculator means it's nothing but the method name is called synthetic division. So how to solve the cubic equation? Okay. So cubic equation solving the method is called synthetic division. The name is called synthetic. It is like a trial and error method only. How we have to solve? The corresponding coefficient first only you write lambda cube coefficient 1. So lambda square coefficient minus 2. Lambda coefficient minus 5. If any of the elements are not there, so you have to consider to be the 0. So on proceed on. Okay. So if lambda is not given means corresponding you have to write to be the 0 here, the position. So the method we have to solve it like this. Fixed here 0, fix here 0. We have to make it here 0. So this element we don't know. We are going into to try it. Okay, for a 1, 2, 3, minus 1, minus 2, minus 3. All the 6 you try it. Within this we will get the any one of the solution. So first we have to try here. Okay, so n equal to 1, n equal to 2, n equal to like that. So first I will try it for n equal to 1. So normal calculation has to be done in the down of this. So it is 1 plus 0, 1. 1 into, okay, this corresponding down into the corresponding element here quotients. Okay, so 1 into 1 placed inside the next element. So 1. So minus 1 into 1. So it is minus 1. So minus 6. So minus 6 into 1, it's minus 6. So it becomes 0. So 1 is here, one of your eigenvalue. Lambda to be 1. One of your eigenvalue we have found, it is 1. Okay, another two eigenvalues you have to found. So how we can find it means this is in the equation format. Now the equation was there, we have written the coefficient, same coefficient was there, we can write it in terms of equation, then you can solve it, or they proceed with the same procedure like this, you can continue. So now when I write it in a equation format, it was cubic equation, now quadratic equation. So it is nothing but lambda squared minus lambda minus 6 equal to 0. So now it is quadratic equation, everyone know to solve. Quadratic equation, write it in a two parts. So how can I write it? So it is in multiples. So lambda minus 3 into lambda plus 2. You multiply, check it. So lambda squared minus lambda minus 6. X, it's correct. So lambda will be 1, okay, minus 2, so 3. So we got 3 lambdas. This lambda is called eigenvalue. This lambda is called eigenvalues. We have 3 cross 3 matrices. So the eigenvalues are 1, minus 2, 3. So completed. Eigenvalues has been completed. We have to next step find the eigenvector. Okay. So eigenvector. So eigenvector we have to find. Eigenvector, how we can find it means we know that it is nothing but a minus lambda I equal to into x equal to 0. X is now column vector. It's nothing but it is x1, x2, x3 because it is a 3 cross 3 matrices. So x1, x2 and x3. So now we write it in this format. So when I'm able to write in this format is nothing but already we know that it is 2 minus lambda minus 2, 3, 1, 1 minus lambda. So 1, 1, 3 minus 1 minus lambda into x1, x2, x3 equal to 0, 0, 0. So now this is our equation format for eigenvector. Now substitute the eigenvalue you take, it is all are three different. So when it is three different eigenvalue, take any one. It may be any one, our guess. Okay. So when lambda equal to 1, I am taking when lambda equal to 1. So substitute in this lambda equal to 1. So when I substitute in this lambda equal to 1, so lambda equal to 1 when I substitute. So what I will be getting lambda equal to 1 and I substitute. Okay, so it is 1 I have to substitute. So in this I have to put 1. So 2 minus 1, 1. Here minus 2. Here 3. Here in this 1 minus 1, so it is 0, no? 0, 1, third equation 1, 3, so minus 2 into x1, x2, x3 equal to 0, 0. Write this in terms of equation format, 3 different equation. Okay. So sometimes the same equation you may get. Okay. So which I will take. So when I take it, so x1 minus 2x2 plus 3x3 equal to 0, first equation. X1 plus x3 equal to 0. X1 plus 3 x2 minus 2x3 equal to 0. I got 3 equation. Okay, you can take any 2 equation. It is your wish. Any 2 different equation. Okay. So when I take it, any 2 different equation, first 2 equation I am going to take it and solve it. The method name is called cross multiplication rule. Okay, how we have to first take it means, if any elements are not there, consider to be, write that equation to be 0 x2 so that you will not get any confusion. So I am written like this way. So the method name is called cross multiplication rule. Cross multiplication rule. Okay. So what I am going to do now, find out your x1 and x2. So it is x1 divided by minus x2 divided by x3 divided by. So how we have to do means, consider only x1 you have to leave it. Okay, x1 you have to hide it. Okay, x1 when you do it, x1 you have to hide it. Okay, x1 you should not consider at all. Okay. So remaining only in the determinant format. Remaining only in the determinant format. So now next one I am not going to consider it. So minus 2, 3, 0, 1. So completed. Same way x2 you should not consider it. Remaining in a determinant format. 1, 3, 1, 1. Okay, same way here. 1, minus 2, 1, 0. So calculate this answer. Minus 2. And this 1 minus 3. 1 minus 3, so minus 2, in this 0, 2. Okay, correct. So completed. Now write it in a vector format, commonly divided by 2. So after dividing only you have to write your vector. Now answer is minus 1. Okay, so here minus minus plus 1, 1. Okay, you may ask question, why you are commonly dividing? If I did not divide, if I write as minus 2, 2, 2. So it will not do anything in finding a eigenvalue and eigenvector. But when you do it in your later chapter, last or 3 or 4th chapter, diagonalization or reduced to quadratic form, in that case, it will affect your table. Okay, because when you do the calculation, when you have a larger number, the matrix multiplication, you feel very difficult. For that reason only common factors can be divided. Okay, it's not wrong. Not dividing means it's not wrong. Okay, one vector completed. We have to go with the second vector finding. Okay, what is our second vector? For that we have to take the vector to be when lambda equal to minus 2. Same format. Lambda equal to minus 2, you substitute in the given equation. When I substitute, so what is our equation? So when I substitute in this, I'll be getting lambda equal to minus 2, minus 2, minus 2, 4. So 4 minus 2, so 3, we're getting lambda equal to minus 2. So 1 minus 2 means 3, 1. Okay. So here 1, 3, 1. Okay. Into x1, x2, x3 equal to 0, 0, 0. So completed. Now you check the equation. Only one equation it is the same. So that you need not repeat it. Only which is non-repeated equation we are going to write. First equation, second equation, third equation I am not writing. The reason, because it is repeated equation. If I repeat also it is same only. Now I am going to solve by cross multiplication. I have a two equations now. Cross multiplication rule, I am going to solve it. So when I solve by cross multiplication rule again, it is nothing but x1 divided by minus x2 divided by x3 divided by. So now x1 is minus 2, 3, 3, 1. x2 is 4, 3, 1, 1. x3 is 4 minus 2, 1, 3. Okay, now I do the calculation minus 2 minus 6. So minus 2 minus 6 minus 9, no, sorry, minus 2 minus 9 minus 11 answer. Okay, here 4 minus 3, 1. In this 12 plus 2, so 14 I am getting. Correct? Okay, the answer will be, I am not able to divide any common number. So I will write the vector as it is. x2 vector is minus 11. Here one more minus symbol, minus 1, 14. Okay, so this is the second vector. When you write here minus symbol, you have to cross check it, simplify that and you write it. The only mistake we do, that only we will interchange and write. Okay, if we are doing that mistake, then the whole question, not in this. So in previous, in the later chapter and all, we may do mistakes. Okay. So second vector completed. Same way go with your third vector when lambda equal to 3. So lambda equal to 3 you substitute in the equation. So you'll be getting equation. So when I substitute it, I'm getting minus 1, minus 2, 3, 1, minus 2, 1, 1, 3, minus 4. So into x1, x2, x3 equal to 0, 0, 0. Okay. So now we have again three set of equation. So I'll write all the three set of equation minus x1 minus 2x2 plus 3x3 equal to 0. x1 minus 2x2 plus x3 equal to 0. x1 plus 3 x2 minus 4 x3 equal to 0. Take any two equation, our wish only first two equation or any other equation. So when we take any two equation, it may be any equation, but the answer will be same for all. Okay. So now by cross multiplication rule, so when I do it, so it is nothing but x1 equal to minus x2 equal to x3. Okay, now x1 is nothing but I am taking first two equation. So when I take it minus 2, 3, minus 2, 1. Okay. x2 when you take it minus 1, 3, 1, 1. x3 when you take it minus 1, minus 2, 1, minus 2. So when I simplify it, minus 2 plus 6. So 4, okay. In this simplification, minus 1 minus 3, so minus 4. In this 2 plus 2, so 4. So what will be commonly divided by 4? Okay, so my third vector will be, check with the symbol when you write it, 1 minus minus plus, so 1, here only plus, so 1 1 1. So my third vector will be 1 1 1 1. Okay, so like this way only you have to calculate it. All the three eigenvector and eigenvalue we have calculated. Next topic will be a type 2. Okay, in the next video. Thank you.